All right, Neil claims that the value of the PMCC shows that there's positive correlation between the mass of a car and its CO2 emissions. Test Neil's claim using a 5% significance level. So when it comes to PMCC hypothesis testing, between two variables, we always assume they are independent, meaning the population coefficient is random. There is no correlation between the two. But I want to test if there's positive correlation. I want to test if P is bigger than 0. The next thing we do is calculate the critical region. So for that, we go on our table. Yeah, this is what the Edexcel's one looks like. The AQA one and the OCR one look similar, but this is just what the Edexcel one looks like. Now we're reading off 9 pieces of data. Yeah, in the table there's 9 pieces of data, and we're testing at 5%. Yeah, 5% here. So our critical value is 0.5822. If you're more than that, we can safely say, using a 95% confidence region, that is positive correlation. So what we say is that our critical region is any R value bigger than 0.5822. And look at R value, we got 0.671, which is greater than 0.5822. So we say, what? Do we reject or accept H0 if we're within the critical region? We reject H0, exactly. We reject H0. There's sufficient evidence to suggest it's always the same conclusion. Suggest positive correlation. I'm just going to say CORR between what? Mass and CO2 emissions. I'm just going to say EMM. Yeah. Okay, a company makes tins of soup. The amount of soup in milliliters S is normally distributed with mean mu and standard deviation 3.5. Given that 3% of tins contain more than 750 mils of soup, find the value of mu to 1 dp. All right, so S is normally distributed with mean mu, standard deviation 3.5. Given that 3% contain more than 750, find mu. So what would you guys recommend I do for something like this? We draw a diagram, yeah? So we are going to have to convert. But we should just do a diagram just to double check. So we have mu, we have the standard deviation of 3.5. Now it's saying 750, more than that is 0.03. Yeah. Now in order for us to use the inverse normal, we need to write a cumulative statement. Cumulative meaning less than 750. So the probability that S is less than 750 is actually 0.97. Yeah. Now, one thing that you should be familiar with is that when we convert to Z to introduce mu into this, because we don't know what mu is, the cumulative Z distribution has a symbol known as phi. So you write phi and then you convert. So you take your number, subtract the mean, divided by the standard deviation. Yeah, this is the cumulative Z distribution. Yeah, that's the technical word. And there have been exams that require you to understand what phi is. Yeah, you don't lose marks if you don't write phi, but you should be familiar with its usage. Now we do inverse, and the reason is because we have to do inverse phi. It tells us that we have to use the inverse normal distribution. So there we go, menu 7. Number 3 for inverse normal. The area is 0.97. These are all different now. Oh wait, sorry. Sigma is now 1, isn't it? Because we've converted to Z. Mu is 0. So 1.8807 ... So it's the cumulative Z distribution, not the same as Z, but it's all the Z values up until the point we're interested in. Okay, guys, I'm just going to times these two numbers together. And then I'm going to minus them from 750 to get mu. I'm kind of skipping a couple of steps here. But here we're going to go menu 1. We're going to do 3.5 times the answer. And we're going to do 750 minus that to rearrange for mu. See, about 743.9. 4. Yeah, so mu. Oh wait, why am I writing that again? 743.4.
Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video.
So we need to go horizontal and we need to go vertical. Yeah, good. So this will be 30 cos theta and 30 sine theta. What is this? This is A, sorry. So guys, are we going to consider the vertical or the horizontal for part A? Now, the way I lay this out with my students is we write vertical and horizontal, but really for this one, write both of them. But vertical is suvat. Hey, Aman. Horizontal is distance is speed times time. And the reason for that is because the horizontal has no acceleration. Yeah, it's not moving under any acceleration. But yeah, we're going to look at S. Now, what is S at B? What is S at B? Minus 20. The reason for that is we're taking upwards to be positive. It's being projected upwards. So at B, it's below the point of projection. Because then we can say U is 30 sine theta. Because if you say S is 20, you have to let U be minus 30 sine theta, which in terms of the diagram can look quite confusing. Yeah. We don't know V there. And A is minus 9.8. And T is 5. So SU, A and T is S is U, T plus half of A. Half of A is minus 4.9 times T squared. Let's move that over. So it'll be 4.9 times 5 squared minus 20. So 102.5 is 150 sine theta. Divide by 150 is that. Then we just do inverse sine of that. And I think I'm in degrees mode. Let me just double check. Inverse sine answer. And that we're going to do to SF because we use gravity. And we use this 43 degrees in the next part.